Is that fine? Okay. So our first program is given on this simulation tool. Okay. Let us give the program name. First, what we need to do, we need to go through the compiler. Click on the compiler screen. Okay. So then in the high-level programming language, the programs will be written on the compiler editor. So let us assume that the compiler editor is open here. So then we can write the program in the program source or input program editor. Okay. So the name of the program as per the lab assignment, let me give the name. It is program that starts the program. And the name of the program is test1. So then I'm going to declare 4 different variables to give this demo. Okay, writing a program for the integer value, like the variable type is integer. Okay, the integer variable. And its data type is integer type. And define the second variable like a Boolean variable for true and false cases for checking the condition. So let me give the variable name as Boolean variable, and its type is a Boolean type. Let me define the third variable like a string variable. Let me say string variable 1, and its type is string type, data type, and give the size. Let me give the size of this first string is, for example, 5 as per assignment. Then declare the another variable like string str, string variable 2, and it is a string type, and give the size up to suppose 20 characters. Okay. So these are the variable declarations. Then writing a simple program like if integer variable which we have given the name here is equal to suppose 6, then repeat the reading the string 1 and string 2. So reading the string 1, the string variable which we have given is string variable 1 is equals to, select the double quotes from the keyboard and give the string like hello. Then from second string, the second string variable 2, so that is equal to suppose, then select double quotes and write that and again, hello and again. So let me write another name as and again. Okay. So then the program is end. So this is our first program in the lab. This is the first program in the lab, correct? Yeah. So now what's the next? There are some reflection questions, right? There are some reflection questions. So to answer the reflection questions, first you look at here, the program is created in the compiler editor, but it is not yet compiled. Not yet compiled. So that's why the program code is not there in the instruction memory. That is what we need to observe. Okay. So let me first compile this program. So to compile this program, go to the compile tab here. Go to the compile tab, click on the compile, then click on the compile tab. So that will compile this program And then we just try to recall what are the different phases of the compiler, which we discussed in the previous lectures. So click on compile. So this, if there is no error in this program, that will compile this and gives the details here. Okay, so the first phase of the compiler is the lexical analyzer phase. So that is tokenizing the source statements, these statements. Okay, tokenizing these source statements. So how many tokens are there here? How many tokens are there? 6. So here I just, for looping, I just missed one. Here we have created the Boolean variable here. So let me create another program here, that is the variable Boolean variable, the Boolean variable that gives the condition that whether it is true or false. So let us say this program will continue until this condition is true. So let me recompile it, the program. Okay. So then you just check it out. How many tokens are there here? How many tokens are found? Total, how many tokens are found? 37. Yes. So that is the first answer of your first reflection question. What is the first reflection question? Tokens, number of tokens. Does that make sense now? Is this easy to understand? Good. Okay. So the next one is, it's showing what are the entry tables. What are the entry tables? So click on the compiler side, come down in the compiler, click on show symbol table. Click on symbol table. So it will show you the symbols. But now you just analyze, the first phase is tokenizing this. Second phase, construct the symbol table. So in the symbol table, it is constructing that 4 variables are declared. That is integer variable, Boolean variable, string variable 1, string variable 2. So in which context? It is in test program 1. What are their types? The integer variable 1 is integer type, Boolean variable 1 is Boolean, and the remaining 2 are string types. So what is the size of the memory reserved for integer is 2 bytes, for Boolean also 2 bytes, and for string 1 it is 7 bytes, that is 5 bytes plus 2 bytes reserved. Then string variable 20 bytes which we declared plus 2 bytes is 22. So these variables are stored in the memory at which address? It is address 6, then 9, then 6. So here there is an override for string 1. Okay. So once this is compiled, okay, the second question is, in the reflection asked that what is the entry in the symbol table? So these are the entry in the symbol table. Is that clear? Is this clear? Does that make sense? Good. Okay, so that's the second answer. So third one is, we need to check how many instructions are there. So once it is compiled, these instructions are created, right? So instruction 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So total number of instructions are the instruction count is 23. So that's the third question in the reflection. Is it clear?
Excuse me, sir, may I ask a question?
Yes, please.
I don't think I got that many instructions for mine. I only got like
Yeah, if you write this code correctly, you will get 23 instructions after compiling.
I only got 9, but I don't see the difference in like the instructions or anything.
Can you share your screen?
Yes.
Yes, please. Okay. So there are total 14 data transfer instructions are there. If you are having doubt, you can go to these instructions. Then if you click on show instructions in the data transfer, move instruction, load byte, okay, store byte, store word, all are comes under the data transfer instruction set architecture. Correct? So from this compiler, you just check it out. Total 14 instructions are there. The next one, in the reflection, the next question asks that, what is control transfer instructions? So control transfer instructions. So if you go to, okay, let me just minimize this. Go to show instruction. In control transfer instructions means like jump instruction, jump equals to, jump not equals to. So if you go and check how many the control transfer instructions are there, means here one is jump not equals to 41 is one, jump not equals to 90 is one. So there are two control transfer instructions. And how many comparison instructions are there means, if you count the number of comparison instructions, here is one comparison, and then here is another comparison. There are two comparison instructions. Then how many mathematical instructions means performing add operation? Here is one and here is two. There are two math operations. Sorry, let me just go back. This is 1, 2, 3, and 4. 4 math instructions are there. And then what is the first address of the instruction means, that is 000 here. And what is the first entry? So these are the the values which are coming from this instruction, right? So now the program is created, that is compiled, okay, but not yet executed. So the compiler generated the code. That generating the code in the fourth phase, that is creating the instructions, CPU instructions here. Okay, so that we called code generation. The code generation is completed. So this code we call the assembly code. So the program not yet started executing. So what happens first, the program code will be loaded into the instruction memory. So load into the instruction memory by clicking on load in. This instructions will be loaded into the memory. The code is successfully loaded into the memory. Is that clear? Good. Okay. So now the program is ready for execution. So what is the program counter? Program counter is holding the address of the first instruction for execution, that is 0, the logical address. And in the general purpose register, okay, in the general purpose registers, no values are there. So for execution by the CPU, okay, these values will be first loaded into CPU temporary registers we call general purpose registers first. So how it will be done in the execution of these instructions that takes place in the three-step process. First, from this memory, the instruction will be fetched and load into the instruction register. At this moment, the instruction register is not having any instructions for execution. Right? So then what happens? First, fetch the instruction which is at the address 0. Okay, that is the fetching part. So the instruction move 6 into R0 register, that instruction is fetched from the memory and loaded into the instruction memory, which is the implicit memory of CPU. Right? So then this instruction will be decoded. So in decode process, what is the operation code and what are the operands? So this is a memory instruction. So when it is decoded, by clicking on decode, the operation is decoded. That is the move operation. So the copy of this data is moving from main memory into the CPU memory. That is the instruction register memory. Okay. So then if you click on show program data here, so in the program data, if you recall the CPU simulator, if you recall the theoretical architecture, there we find the Harvard architecture. The memory is separated. The instruction memory used to store the instructions and data memory is used to store the data. So what is the data in our program? The data is hello and again is the data. So that is stored in the data memory, that is starting from the location from 43, 43rd byte, then the 48 byte, it's keep going on. So these byte values are changed. When there is no data, so no bytes are there. So if you look at it in each byte, the value hello is started from byte 0. Byte 0 is 67. Okay, so this is the ASCII value of this. So if you click on here, you find in byte 48, the first character is there, H. In the next byte, E is there, next byte, L is there, next byte, L is there, next byte, O is there. Okay. So now see this, after executing this, see the difference, how these values will be updated. Okay. So now in the instruction memory, let us see the first execution. If you click on execute, okay, let me just show here. Let me keep this on top. Okay, so upon executing this, the value 6 is moved into R2 register. The 6 is moved into R2 register. So this 6 is the immediate value that is moved into the temporary register R0. Is it clear? Okay. So after compiling, this data is at this memory locations. So that is given here from the physical address and the logical addresses here. So the logical addresses is mentioned here. Okay. So the next, just observe here by running this program. Okay. By running this program, how these values will be changed. So the data will be read from these locations and write into the new location here. Because moving the value 6 into R02, then store the word 6 into the register, store word. Okay. So just observe, by just running this, observe this simulation. Let me run this and see the observation here. The character by character is reading from this memory and going to write into the new memory location here. So the first character H is read from this memory location and write into this memory location. Okay. So you can see the changes here from byte 6 onwards. It's reading character by character. Okay. So this is how you need to create a program and run the program, okay, to observe how the high-level programming language written in the compiler, and that compiler generates the instructions, then the instructions load into instruction memory, then the execution starts. So once the data is read from this memory location, that will write into the new location. So ultimately, the execution of this program done in 1 minute, 6 seconds, 120 nanoseconds. So this is CPU runtime. So in the next lecture, we are going to talk about the CPU performance based on the runtime. Based on the runtime. So this is the overall demo for creating the program and running the program. Follow the same steps for all the remaining programming tests, and you can get the reflection values. Okay.